Hi, I'm Lokesh and this is a URL shortener I built and deployed on AWS. So it is running on a K3s cluster with full CI/CD monitoring and GitOps deployment. So let me show you how it works and how it is built. So, so this is the input box where you paste your long URL. Let me paste one, and there is a shorten URL button. So click on it. So now you can copy the shortened URL. Now go to the other tab and paste it. So you can see our redirected destination, right? So yeah, so so the app is pretty simple. You give it a long URL and it gives you back a short one, right? So after knowing the application, let's talk about its architecture. So after coming into the repository, click on the docs folder and then there you will see architecture.md file. Then if you scroll down a bit, then there you'll see the current implementation. So the current implementation, yeah, right. So the current implementation is pretty simple. I'm running this on AWS with a K3s cluster on EC2, and the traffic comes through the Route 53 to traffic ingress controller, as you can see in here, right. So I have created a record mapping my clck.dev to the EC2 elastic IP, not public, right, because public IP changes every time if we stop the EC2 instance and then start again, right. So yeah, and then the traffic ingress controller routes to either the React frontend or Go API backend pods, as you can see here, right. And then the API uses Redis for the caching and MySQL RDS for persistent. So everything is monitored with the Prometheus and Grafana pods, right. And I have defined some custom metrics in the Grafana dashboard that that monitors the total API request count and the total API request bytes, endpoints, also the go routine and everything, right. So with that we will see later. So yeah, and then now you might be thinking why K3s and not EKS. That is mainly because of the budget. So I'm a student spending about $220 a month, actually not spending but using the AWS credit on a free trial. So thanks to AWS, yes. uh, so using EKS would have added another $75 just for the control plane. So I am managing K3s myself, so which gives me hands-on experience with Kubernetes without the managed service cost, right. So like if we go back, so if we go back and then current implementation, and then this is the image. If you restart it, yeah. So yeah, this is my future architecture if I would have budget. So nothing fancy. I would have used my private VPC and then grouped my instances into the private and public subnet, right. And then if someday if I want to SSH into my private subnet, then I would have placed a bastion server into the public subnet, and then from that bastion server I would have do SSH into the private subnet, right. So instead of let's encrypt that I was using for the SSL, right, so I would have used the application load balancer for the for the load balancing as well as for the free SSL that it gives, right. And then it would have also acted as a rate limiter, global rate limiter for my application, okay. And then uh, multi-easy RDS, right. And then everything is pretty same, right. So now let's do SSH into the server. Then let's go here and then go to the EC2, go to the instances, click on master node, and then here I have a public IP address. So if I do SSH -i pam u12 and it. So I am into the server. If I do sudo -i, and now I am as a root user, right. So let's see the namespaces first. So what is namespace? Namespace is the uh, isolation, right? It creates the isolation between our pods, right? So that the pods from the different namespaces cannot interfere each other, right? So right. So kubectl get ns kubectl get ns, right? So we have these namespaces, right? So API namespace is for my application. So in the API namespace, I have my API and my front end, right? And the Argo CD, my Argo CD is running, and for the monitoring, my Grafana Prometheus is running, right? So if I see my current namespace, so kubectl config view, so right. So my current namespace is default, right? Default. So let's go into so if I want to see the all the pods, get pods hyphen a. So what it will say, it will list the all the pods that are running. So in the API namespace, I have one API, right? And the API namespace itself, we have our front-end application pod also, right? And in the Argo CD namespace, so these are the pods that is running. And in the monitoring, as you can see, Prometheus, right? Grafana, right? So let's switch our namespace. kubectl config set hyphen context hyphen current hyphen namespace equals to API, right? So now I have changed. So kubectl config view, as you can see, it is the API, right? So now let's see the pods again, right? So it is running, so the pods is healthy. So if you want to see the kubectl logs, and then if you want to pod and then kubectl logs pod, right? Okay, so kubectl logs, so it is running, right? As you can see. So yeah, this is pretty much. So now let's talk about the monitoring. So let's come to the dashboard. So this is my custom dashboard that I have created for my application. So as you can see, so basically there are 6 panels, right? And the first panel displays like the our total request, right? Total request per second. And then the second panel displays uh, the request by the endpoints, right? So as you can see, right? As you can see, so these are mostly the health check, because I don't have a real user yet. So the P95 latency dashboard panel, so what it does is it tells us like the 95% of the requests are completed within the specific time, and the 5% of the latency taking longer, from the request taking longer, right? So 5x error rates means the 500 the error that I got, so there are no yet. So these are the memory uses, basic, it is stable, and the go routine is also stable. So yeah, this is about the uh, custom. So but we can also see about my pod. Yes, this is the CPU usage, CPU throttling, everything is pretty much normal. So everything is deployed through the GitOps with Argo CD, and Git is the source of truth. So whatever is in my KTest folder is what runs in my production. So if we go back to the URL shortener, and then if you see the KTest, so yes, so this is the folder that is in sync with my Argo CD, right? So if I go here, so So you can see all the resources Argo CD manages, deployment services, ingress, config map, everything is synced and healthy. So yeah, as you can see, right. So I have auto sync enabled, as you can see here, and uh, and so when I push changes to the Git, Argo CD automatically deploys them. So it also has self heal enable. If someone manually changes something in the cluster, Argo CD reverts it back to the match Git, right. So if I go to here, not here, if I go to the sync status, yeah, you can see here automated sync policy, right. So let me show you the deployment process. I'm going to make a small change to the front end. So I go to the front end. So let's go to the source folder and let's go to the URL shortener. So so as you can see, let's say we have in the title we have CLK simple URL shortener, right. So let's change it to the from simple to the, let's keep it only URL shortener, CLCK URL shortener, right. So let's go to the public. So it in public in the index.html. So here we'll be having simple, right. So I will be editing the file here only, and then I will be changing here, but it should not change directly like from the GitHub repo. So I'm committing, right. So right. So now if I switch to Jenkins, so if I do the refresh, so if I come here, as you can see, it already picked up, right. So now if I go to the pipeline overview, so it already did to install cleanup workspace, checkout from Git, as you can see. So it is running because it is the web pipeline, because I have changed the front end, so it is running the web pipeline, is installing the dependency, and then now it is going through this on R-cube, right. Quality gate checks, as you can see, right. Dependency check, right. Now it is analyzing. Okay. Right. So now it is mini, right. And it will push to the Docker hub. So now it is pushing to the Docker hub. Right. So now previous version, it is scanning the Docker image for any vulnerability, right. Now it is sending email, right. So as you can see, our pipeline is executed. So if I go to the here and then if I go to the console output, it will say success pipeline, right, in the end. Success, right. So if I quickly go to the Argo CD, right. So if I do the refresh, right. So as you will see, it is loading, right, and the web app is loading because it is deploying. So Argo CD picked up this because if you go to the URL shortener, so yes, so as you come here, so our Jenkins changed the image name into the web-deployment.yaml into the KTS folder, and KTS folder is already been monitored by the Argo CD, right. So Argo CD picked up the change, and then it is now deploying. As you can see, it is deployed few seconds ago, right. And if I go back to the here, and then if I check the logs, it is working fine, right. So now if I go to the clck.dev, so simple URL shortener should be changed to the URL shortener only, right. So if I do the refresh, so as you can see, it is changed to the URL shortener. So that is the system. To summarize, URL shortener that I built with the Go and the React, that is deployed on AWS with K3s self-managed cluster, and full CI/CD pipeline that is with Jenkins, and GitOps deployment with the Argo CD, and monitoring with Prometheus and Grafana. Everything documented in the GitHub repo. If you are super interested in, or contributing it, I mean, if you want to also use it for your personal use, then you can use it. So you can check out the repo, right? This is the repo. No. So the interesting part about the project was not just building the app. So it was learning how to deploy, monitor, and operate it in production. So I made deliberate trade-offs based on budget constraints, but I designed it with the production patterns in mind. See, all the code documentation and architecture diagram are on the GitHub. And thanks for watching. Thank you, guys.